This is Algebra 1B, and we're factoring trinomials. These are quadratic trinomials because of the squared when a is greater than 1. In other words, when the number in front of the squared term is something other than 1. I'm not just looking for number pairs, and in fact, there's nothing that multiplies to -5 that also adds to -2. So I'm not using that number pair pattern that we've tried before. Instead, we have a couple of ways we could try this one. I'm going to show you the guess and check method first. I have two different binomials that are going to be multiplied by each other, and together the leading terms both have to multiply to 3p squared. Because this is a prime number, I know it's going to have to be 3p and 1p. If it was a number like 6p squared, it could be 6p and 1p, or 3p and 2p, so this makes it easier for me. I know that's going to be true. Also, my last number is prime, and it's negative. The only things that multiply to a -5 are positive and negative 1 and 5. So I'm going to do a little bit of trial and error first. What if I do -5 plus 1? And I multiply all this out. 3p times p is 3p squared. Great. -5 times 1 is -5. That's great. Now to check the middle term, -5 times p is -5p. 3p times 1 is positive 3p. And when we combine those together, that's the -2p we needed in the middle. So my answer is correct. I do have this factored correctly. I did it by a little bit of guess and check. Fortunately for me, I guessed the right one the first time. But if that didn't work, I could have tried something else, maybe like 3p minus 1, p plus 5. Still, 3p times p is 3p squared. -1 times 5 is -5. But if I had tried this one and multiplied the middle terms, multiplied the outside terms, this doesn't combine to that -2p, so it wouldn't have worked. So I'll go back earlier to the one I happened to just guess correctly at the very beginning. It was 3p minus 5, p plus 1. That is our answer. Multiplying all this out would give us to the original, and that's just using guess and check. Now on this next one to the right, I see the last number isn't prime, so using guess and check probably wouldn't be my method of choice. This is called the split middle term. Again, I'm not just multiplying to -9 and adding to 3. Because there's the number out front, that just doesn't work. Instead, I'm going to multiply 2 times -9, and that's -18. And I'm looking for two numbers that multiply to -18, but add up to 3. So to get to 18, there's 1 and 18, there's 2 and 9, 3 and 6, 4 doesn't work, 5 doesn't work, 6 is in my pair. So these all multiply to a positive 18. I need to get to a -18, which means one of the numbers is negative, and they have to add up to a positive 3. So this one's out, this one's out. Here's my winning pair. If the 3 is negative, these will add up to a positive 3. So we are going to split the middle term using these two numbers. 2n squared stays what it is. Here's the 3n. This is the middle term that's going to be split. I'm going to call it -3n plus 6n. This has an n on it. These both have n on it. This is the same thing. Adding these two together is still 3n. So all I did is I just manipulated it a little bit, and I split it into these two terms using this pair from over here, and then I'll bring down this -9 at the end. So I've set it up to do the grouping now. Grouping is a method that we've looked at earlier. I'll group the first two, group the last two, then look for a GCF. What do these have in common? Just an n. 2n minus 3. Then look at the last two terms. What do these two terms have in common? It's a 3. 3 times 2n, it gives us the 6n. 3 times -3 gives us the -9. And if it's possible, and if I did everything correct, these should be exactly the same. So it's going to factor as 2n minus 3 times n plus 3. I believe this is the correct answer. Now in the first one, I just went to straight guess and check because everything was in prime. I'm going to check to make sure this works. So n times 2n, there's the 2n squared. 3 times negative 3, there's the negative 9. Here's the tricky one. 3 times 2n is 6n. N times negative 3 is negative 3n. This is that 3n we have in the middle, so I'm feeling pretty good about my answer. There it is, completely factored. Let's look at this problem next and give yourself a chance to copy it down, maybe pause the video, see if you can remember what we did on the last one. We do have bigger numbers this time. 5 is a prime number, I like that, but because this one is a composite number, I'm not just going to go straight to guess and check. Instead, 5 times 12 is 60. The reason we have to do that is because there's a number in front of our n squared. What multiplies to 60? 60 divided by 2 is 30. 60 divided by 3 is 20. 60 divided by 4 is 15. 60 divided by 5 is 12. 60 divided by 6 is 10. Lots of numbers so far. 60 divided by 7 doesn't work. 60 divided by 8 doesn't work. 60 divided by 9 doesn't work. There's 10. Here's all of our pairs. 5 times 12 is 60. The different factors that multiply into 60. Now we want the winning combination that's going to add up to this middle term of 19n. Four and 15 is our winning combination. So we split it again. Split middle term is the method. We split it as 4n plus 15n. And you could have written the 15n first and the 4n second. That wouldn't matter. This comes down exactly the same, and this comes down exactly the same. The original problem in yellow and what I have in blue should be 100% equivalent to each other. It's just that this middle term has been split up. The 5n squared, the 12 are exactly the same as the original. 4 terms means we're going to try grouping. The first GCF, greatest common factor, is n, 5n plus 4. And then the second GCF, what do these terms have in common, is 3, 5n plus 4. Insides are the same, so we have 5n plus 4, and then the GCFs of n plus 3. I believe this is correct. Here's my quick check. N times 5n, there is the 5n squared. 3 times 4, there is the 12 at the end. And now the hard one. 3 times 5n is 15n. N times 4 is 4n. Together, there is that 19n. So there's our answer, factored completely. Let me scroll down a little bit more, and let's try number 9. Number 9 has some big numbers to begin with, but we can make it easier on ourselves, as we should do on any kind of factoring problem, and look for a GCF first. And in fact, there is a GCF this time. 3 will go into all those terms. And what we've just done is we've made these numbers a lot smaller, which should make things simpler. I'll bring down this 3 and carry it on till later. And now look at factoring this inside. You can try the trial and error method, because this is a prime number and this is a prime number. Or you could do the split middle term, the process that we've done a couple of times now. I'm going to try the split middle term. 5 times negative 2 is negative 10. The only things that multiply to 10 are 1 and 10, 2 and 5. These are supposed to multiply to a negative 10, so one number is negative. They're supposed to add to a negative 9. This is our combination with a 10 being negative. So we split the middle term. We have a positive 1n, a negative 10n. Bring the 5n squared down, bring down the negative 2. Group, group, group. GCFs, n goes into both of those. Negative 2 goes into both of these. Negative 2 goes into both of those terms. Insides are the same. We needed that. So it's 5n plus 1, n minus 2 with this GCF from the very beginning of 3 that needs to be brought down. Then the second part of this section is going to be on factoring quadratics a greater than 1, where we're going to solve. So if you notice in all these examples we have coming up, there is an equal sign in there. And when we factor, we want them always to be equal to 0. So don't subtract 14 and then try to take a GCF. We're going to factor this left-hand side of it. 2 is a nice prime number, but 14 isn't. There is no GCF for all of them, so I'm going to try that split middle term. 2 times 14 is 28. What multiplies to 28? 1 and 28, 2 and 14, 3 doesn't work, 4 and 7, 5 and 6 don't work. So here's all the pairs. We need to add up to not just 11, but negative 11. Here's going to be the pair as long as they are both negative. So we're going to split that middle term, keep 2k squared, but the negative 11k is minus 4k minus 7k. This is equivalent to this. It's just split up, plus the 14 equals 0. And regroup. First GCF is 2k. Inside the parentheses is k minus 2. The second GCF might be a little tricky because there's a negative right here. Remember, we want the insides to match up. We're going to take out a negative 7 instead of just a positive 7. That makes it become k minus 2 on the inside. They are the same. So we have k minus 2 times 2k minus 7 equals 0. And like we've seen with solving in the past, we're going to take each of these factored parts and make them equal to 0. So 2k minus 7 equals 0. We want to solve this equation, so add 7 to both sides, and then divide both sides by 2. So k equals 7 over 2, 3.5, 3.5. There's one of your answers. And then set this equal to 0, k minus 2 equals 0. To solve for k, because it's nice and linear, just add 2 to both sides. We get our other answer of k equals 2. So solve these quadratics. By factoring, we want them equal to 0, and then we factor to solve. I'm going to look over to this problem number 4. Much bigger numbers. There is a GCF at the beginning. We can factor a 3 out of everything. So this problem has a little smaller numbers to begin with. The 3 we can carry down, but the rest of this needs to be factored. 5 is prime, the negative 9 isn't. So we're going to try the split middle term. 5 times negative 9 is negative 45. What multiplies to 45? 1 and 45. 2 doesn't work. 3 and 15. 4 doesn't work. 5 and 9. 6, 7, 8. None of those work. So these are the ones to choose from. We need a negative 45. Add up to a positive 12. So here's the possibilities. No, no. These add up to 12. So we're going to split the middle term. Negative 3v, positive 15v. Carry everything else down exactly the same that it was. Group, 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 group. The first GCF is going to be a v, parentheses 5v minus 3. The second group, the GCF, is going to be a 3, parentheses. Take a 3 out of those, that's 5v minus 3. It looks like it's shaping up nicely, so it's v plus 3. 5v minus 3 equals 0. And then there is this 3 GCF from the beginning. Now that it's completely factored and equal to 0, I'm going to set this equal to 0. Because 0 times anything is 0. So if this is 0, we're good. Add 3 to both sides. Divide by 5. V equals 3/5. Great, I have an answer. v plus 3 equals 0. Subtract 3, so v could also be negative 3. And then this GCF, we set it equal to 0. That's not true. That doesn't mean there's something wrong with the problem. That just means this does not give us another solution. So we only have these two solutions to solve this problem. Let me scroll down a little bit and look at this problem number 7, which has some huge numbers on it. And hopefully we can simplify this down. To begin with, we need this to be equal to 0. So we have to do a little bit of the work to get it equal to 0. In other words, how about subtract 176n, subtract 140 equals 0. There we go. Now, as I'm looking at this, these numbers look horrible, and I don't really know what goes into all of them necessarily, but I can start by taking out at least a 2 because they're all even numbers. And then maybe I can even divide them all by 4. So let's go ahead and try that. 7n squared, 176 divided by 4 is 44. A little better. And then 140 divided by 4 is equal to 35. And then I don't think that they have anything else in common. So I picked a problem that has still has some huge numbers in there. This is prime, but the 35 isn't, so I'm going to have to try this split middle term with a huge number. 7 times negative 35 is negative 245. This will probably be one of the hardest problems that we see because these numbers are so big. What multiplies to 245? Well, I know it's not even, so 2 won't go into it. Try to divide it by 3 and it doesn't work. 245 divided by 5 is 49. To get a negative, one of these numbers has to be negative. We're adding to a negative 44, so thankfully this is the combination that's going to work. Can you rewrite this using this split of that middle term? Still 7n squared, but the negative 44n becomes positive 5n minus 49n. They add up to negative 44. Again, they gave us our correct multiplication. Bring down the negative 35 equals 0. So we have this. Group, 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 group. GCF here is n. 7n plus 5. The back end, I'm going to take out a negative because negative goes into both of them. What number will go into both of those? It's a 7. And if I didn't know, I know that the inside is supposed to be this, so I could check. 7n times this is negative 49n. 5 times this is the negative 35. So completely factored is going to have n minus 7. 7n plus 5 equals 0, taking my like terms, my GCFs. And then there was this 4 at the beginning. This one is a dead end because 4 never equals 0. This one we set equal to 0 and solve it. N equals 7. Nice answer. And then the last one, 7n plus 5 equals 0. Subtract 5, divide by 7. So we get negative 5/7. So n equals 7 and negative 5/7. These are the solutions to that original problem.